So this says, which of the following series diverge? So we're going to do limit as n goes to infinity for each of them. And if it comes out to anything other than 0, then the series diverges. Right, so Roman numeral 1, we've got limit as n goes to infinity, cosine of 2n. So cosine is a wave, and it's just going to keep bouncing between +1 and -1 forever and ever. So that is not leveling off anywhere as we go to infinity. So this limit does not exist. There's no behavior of that graph towards anything in particular as you look to infinity. It's just going to keep on waving. So that one does not exist. So the series diverges. So we do want that one. All right, and then for the second one, limit as n goes to infinity of 1 plus 1 over n. So if n goes to infinity, this part's going to go to 0, and then plus 1 would be 1. So again, if it comes out to anything other than 0, the series diverges. So that one diverges as well. And then the last one here, limit as n goes to infinity of n plus 1 over n squared. And so if n goes to infinity, this part is going to go to 0. So that's going to be gone. And this part is going to go to infinity. So it's just going to head upwards forever and ever. And so that also doesn't equal 0. So that one diverges too. So none of them came out to 0. And so they all diverge. So that one is D. And actually, even if it comes out to 0, that just means that you can't make any conclusion. You can't conclude that it does converge. So you'd have to look at it more closely before you could decide that. All right, so number 2, the nth term test can be used to determine divergence for which of the following series. So again, exactly like what we just did. So we're going to do limit as n goes to infinity for each of these. So, or you know what, they used k. We changed that to k so that it matches. Limit as k goes to infinity of k plus 1 over, oh no, sorry, ln of, missed the ln there. ln of k plus 1 over k. So we do want to look at this inside part first. As that goes to infinity, we have k over k. That's a tie if you're comparing, you know, who's in charge here with the powers. So we're going to use the coefficients, which are both 1, so 1 over 1. And so we end up with ln of 1, which is 0. And so we cannot make any conclusion on that. So we cannot use the nth term test for that one. There's no conclusion that we're going to make there. This next one is alternating. That -1 to the k, we're not going to use that part. That's just the part that makes it go positive, negative, positive, negative. So we're just going to do limit as k goes to infinity of just this part. And so again, comparing who's in charge here, these are both k to the first, so we're going to use the coefficients, which would be 1/2. And since it did not come out to 0, that one is going to diverge. So again, if it comes out to anything other than 0. And then last one of these, limit as k goes to infinity of k squared minus k cubed over 5k cubed. So if we're looking at comparing the powers there, we've got negative k cubed over 5k cubed. And so using the coefficients, that would be -1/5. And so once again, that's not 0. So that one is going to diverge. So we want Roman numeral 2 and 3, and so that one is C. Right, so for number 3, we're given a sub n equals cosine of pi over n, n starting at 1. Which of the following statements about this must be true? So we're going to do the same thing. We're going to do this limit as n goes to infinity of this cosine of pi over n. So if n is going to infinity, this part inside is going to go to 0. You have pi over a billion, you know, it's going to go to nothing as the denominator gets infinitely large. So this is going to be cosine of 0, which is 1. So that did not come out to 0. And so the series diverges. So that one is D. All right, and then number four is a very strange problem. I actually almost debated putting this on here, but then I was like, you know, I don't want to ignore the tougher questions, so we'll still get through it. Interestingly, these two statements are mathematically equivalent, which is kind of neat. You've got this square root of k plus 1 minus square root of k, and that's equal to 1 over blah, 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 right? So you can use whichever version of that sort of suits you as you go through the problem. So for the infinite series, sum k is 1 to infinity of this, which of the following is true? And so the first thing we're going to do is this limit as k goes to infinity. And the easier version of this for me to use is going to be this second one. Because as k goes to infinity, I'm going to have an infinitely large denominator. I mean, even if you square root an infinitely large number, it's still an infinitely large number. So this denominator is going to be astronomically large. And so 1 over a gazillion, that's going to be 0. So that limit is going to go to 0, which means that we can't make any kind of conclusion yet. But I can get rid of B and I can get rid of D. So those are two choices. So you can narrow it down. And so if you were really stuck on this problem on the AP exam, you could narrow it down by doing that and then just kind of make a 50-50 guess, which is good as well, narrowing it down. So now we need to decide if the series converges or diverges. I'm going to list out the first few partial sums. We're going to do sum of 1 term and 2 and then 3, and then try to get, you know, a pattern for what's going on as we add these up. And this time I'm going to use this version of the formula because that's going to be a little bit easier. So if we plug in 1, we're going to get square root of 2 minus square root of 1. And then if we do the sum of the first 2 terms, it's going to be that, which I hope I have enough room here, plus, and then we're going to plug in 2. So that would be square root of 3 minus square root of 2. And then if we add up 3 terms, it's going to be those 2 plus the next one. So if I plug in 3, I'm going to get square root of 4 minus square root of 3. So this is one of those telescoping series. And you know that series recap, that link that I posted for you? I have this on there if you want to look back at it, because we're going to cover a lot with series, and it's going to be nice to have all that information in one place. So if you want to pull that up and look at what it says for telescoping, this is one of those. So looking at what's going to cancel out here, the square root of 2's are going to cancel, the square root of 3's are going to cancel, and that would happen, you know, so on and so forth for as many terms as you wanted. You're always going to have this square root of n plus 1, or I guess I'll call it k for this problem since they use k. You're going to have a square root of k plus 1 minus square root of 1. That square root of 1 is never going to cancel out with anything. That's just always going to be there. And if we do limit as n goes to infinity of this first part, that's going to go to infinity. And if that's not a finite number, then the series diverges. So diverges since this is not a finite number. So that was a telescoping series. And so that, that final answer for that one is C. But if you ever get stuck, just start listing out the first few terms in the series, adding them up, like do the first few partial sums just so you can kind of wrap your mind around what's going on. Actual numbers, I feel like, are always easier to deal with, not evil, easier to deal with than variables, having actual numbers in there. So you can always just make a list. And then the last one, let x be a real number. Which of the following statements about this infinite series is true? This is going to be geometric. I'm going to rewrite it so we can see what A and R are a little bit better. A would be 1. It's not written in here, but that would be 1. And then, you know what? They used K again. I'm so sorry. I'm used to using N. Let me change it to K. This would be e to the x to the k power. So it's A times R to the k. Usually it's n. A times R to the n. But this is A, and e to the x is R. So the sum of the series is A over, so it's going to be 1 over 1 minus R, which is e to the x. So that's either going to be A or B. We can narrow that down. And then they want to know if x should be negative or positive. This R value has to be smaller than 1. So R has to stay smaller than 1. And so for this particular problem, e to the x is going to have to stay smaller than 1. And if we go to solve that for x, we're going to ln both sides so that the ln and the e will cancel. So we'll just have x, and then ln of 1 is 0. So we want x to be smaller than 0, and so that is going to be a. So that one was not necessarily on the nth term test. That was just a geometric series that was reviewed from the class before.